excited to have another executive join us from the ecosystem, and this one's from Pfizer. Joe Cappelleri is the executive director of Biostats and head of the health economics and operations research and outcomes research. For statistics, HEOR statistics at Pfizer, and very excited to have Joe join us here today and again provide the kinds of insights and the kinds of perspective that you all, our community, need in order to not just find the next big thing in digital health to improve patient care using digital technologies, but also the how to invest and how to purchase, how to analyze, evaluate these technologies so that there's the optimal adoption of technologies. The best money is going to the best technologies. And in this situation, again, with what Joe's doing at Pfizer, and we'll learn more about that now, we're going to be looking at this ecosystem around health economics and outcomes research. Joe, how are you?
Hi, Stan. Thank you for your kind invitation. Thanks to HITLAB and inviting me. I'm very grateful and appreciative.
No, of course, and it's great to have you on the program. And again, hundreds of people from around the world are seeing this now. We'll see it in the future here, and obviously a lot of interest in what you do and the work that you do. And if you could just give everyone maybe a 1-minute capstone on your background.
Okay. Well, I earned a Master of Science degree in statistics from the City University of New York, PhD in psychometrics from Cornell University, and Master of Public Health and Epidemiology from Harvard University. I then spent the next 3 years on the faculty at Tufts University Medical Center before joining Pfizer in 1996. And partnering and collaborating with our health economics and outcomes research statistics group. In my group, which I had the HEOR group it's a relatively small group of about 7 of us. We focus on patient-reported outcomes, development and validation of other clinical outcome assessments, meta-analysis, research synthesis, indirect treatment comparisons, network meta-analysis, for example. We also focus on health economics, cost effectiveness, budget impact analyses. And it's been a joy, 28 years and counting.
Amazing. Well, congratulations on that too, Joe. That's really impressive. And I think I'd like to start off, you and I had a nice talk about a month ago, and would love to start off just hearing more about the Palisade checklist. If you could introduce that and explain the significance of it in context of AI and machine learning applications in HEOR.
Right. Oh, thank you for the question, Stan. Palisade, it has a catchy acronym. I'm a New Yorker, so I'm thinking about during our conversation cruising along the Palisades there in New York, the mountains, and enjoying the view. And I'll provide you with the view with special acknowledgement and credit to a publication by Padula and colleagues published in Value in Health in 2020, titled Machine Learning Methods in Health Economics and Outcomes Research, the Palisade Checklist, Good Practices Report of an ISPOR task force. So what I'm sharing with you has its inspiration and content in that wonderful article by Padula and several other wonderful co-authors. The Palisade checklist: P, purpose; A, appropriateness; L, limitations; I, implementation; S, sensitivity; and A, algorithm; and E, explainability. That's what the acronym represents. Purpose is the Palisade checklist involves key considerations for evaluating the transparency of machine learning to stakeholders and decision makers. Regarding that P in Palisade, the purpose is the purpose of the algorithm clearly stated at the outset. It's about transparency. Is the implementation of the algorithm in healthcare setting fair and ethical? The A in Palisade, appropriateness. Is there a clear justification of the algorithm that it is acceptable? in the context to which it is being applied, the particular instance. The L limitations have the strengths and limitations in the context of purpose been identified. This should cover both the algorithm and any data sources used. The S, sensitivity. It also includes specificity. For classification algorithms, has the model performance and accuracy been appropriately evaluated in terms of the diagnostic metrics of sensitivity and specificity? The A, algorithm, specifically algorithm characteristics. Has the machine learning mechanism been clearly characterized and described? Is there sufficient transparency for the results to be reproducible? Common theme: transparency, reproducibility, explainability. The D in Palisade is the selection of the data sets justified and are the key characteristics known. This should extend to the training sets, test sets, and validation sets. And finally, the E, explainability. Are the outputs of the algorithm understandable by both the healthcare professional and the patient? We don't understand, we can't appreciate, and if we can't appreciate, there's little incentive to move forward.
That is fantastic. I'm assuming that pause is you're done.
The pause for theatrical effect. That's correct, Stan.
Phenomenal. No, that's great. And just for the audience's standpoint, I am posting the paper from Science Direct into the chat box. So if you all want to see the paper that Joe is referring to from Padgett et al., just take a look at the link in LinkedIn. Joe, this is great. So obviously this is an enormous checklist and a very important one considering all the work we're doing in AI today. If you could, can you just give us some examples of how AI and machine learning have been successfully applied in the world of HEOR?
Right. Oh, sure. Very good question. We're about practice. So I'm going to give 5 examples, one for each finger of one hand. And in the paper, the Padgett paper, there are 5 major categories. And I'll give an example for each of those 5 categories. One is called feature selection. The example there is to identify drug-drug interactions by data mining. A pilot study of warfarin-associated drug interactions was looked into, and the technique of random forest was applied to predict interventional normalized ratio. A logistic regression was then used for further investigation, and the point is to identify known interactions and potentially new ones. And paper was published in a cardiovascular quality of life journal by Hansen and colleagues to learn, if you wish to learn more about that. The second avenue is predictive analytics, and case study there is improved diagnostic accuracy for diabetic retinopathy. And the machine learning methods were used to provide greater specificity and sensitivity versus other approaches that were previously used that may have more of a tradition, for example, N of 1 diagnoses. Paper by Ting in the Journal of the American Medical Association 2017 goes into that. Causal inference is another area of general area, which we have an example of. This one, probability of a child's being discharged alive from the pediatric intensive care unit by a given day under a range of longitudinal feeding regimens. This is serious condition, and we wish to establish the benefit of that probability and how to deal with it. More information on this is by RIEF in the American Journal of Epidemiology 2017. Goes into the details on how we could refine that probability and do something about it in saving lives and improving quality of life.
That's great.
Yeah, just very briefly, just a couple more. One having to do with economic evaluation and cost effectiveness and hospital resources for effective prevention of pressure injuries. And finally, regarding cohort selection, use of a model-assisted cohort selection application using the Flatiron health data to provide more focus, targeting, classification for effective decision making. Again, all in the Padula paper with references. I've gone into more detail, but the papers will play it out in its full glory.
It's fantastic. And again, I know you're busy, and we got one last question for you here, but I think the key thing here is obviously, AI and machine learning is all very new. And obviously, there's a good chunk of the audience here today that's working with manufacturers and life science companies, and so they're working in HEOR all the time. There's a lot of academics as well. They're in HEOR, and there's a lot of digital health companies that work with HEOR departments. So you've got a lot of experience here. What are some of the pitfalls or misconceptions about AI and machine learning around the HEOR field that your colleagues at startups and others should be aware of, and how is the Palisade checklist helping them?
Yeah, a challenge in the field of machine learning will need to overcome it. That we need to overcome is educating clinicians so that they better understand what machine learning methods produce and why they should be trusted. Related issue is the danger that machine learning algorithms can reinforce bias in healthcare delivery. Underserved populations, for example, by definition, have less representation in healthcare databases. Machine learning algorithms inherently reinforce those patterns through their algorithm, which is an extremely difficult problem to solve. Consistent with the criteria developed in this is poor guidance. The Palisade could afford more collaboration between communities of HEOR scientists and computer scientists with machine learning expertise to encourage that and to expand and build trust in machine learning methods, allowing for transparency and advancement of validation techniques that would make the methods more transparent, reproducible, and meaningful.
Theatrical pause.
Theatrical pause.
All right, Joe. Well, look, this has been tremendous. Again, everyone, you've got the scientific paper Joe referenced to start this off. And Joe, thank you so much for your time today. Really appreciate everything you're offering, and would love to have you back on one of our sessions again in the future.
Thanks again, Stan, and thank you all for listening, and best wishes.